Hi, for this example, what I wanted to do is I want to test for symmetry algebraically using all of the rules that you would use. There are three things that we're going to test for. We're going to test to see if it's symmetric with respect to the x-axis. We're going to see if it's symmetric with respect to the y-axis, and we're also going to see if it's symmetric with respect to the origin. It is possible for it to be symmetric with respect to any one of those three, none of those three, or all of those three. So you always want to just check all of them to see what types of symmetry it has. So for the first one that we're going to start with is the x-axis. And remember, x-axis symmetry means that if I were to fold it over the x-axis, all of my points would line up. And so for this one, what we are going to do is we are going to replace y, our y coordinate, with negative y, because my x coordinates would be the same, but my y coordinates would change signs. So we're going to look at our equation. We have x squared plus y squared equals 4. I'm going to keep x squared the same. I'm going to replace y with negative y. And then I'm going to see if I simplify this, do I end up with the exact same equation? And this does give me the same thing, because if I square a negative, like if I take -4 times -4 or -2 times -2, it's going to give me a positive result. So it's going to just give me whatever that value is squared. So since this is the same, this is symmetric with respect to the x-axis. You don't want to stop there, because it is possible to be symmetric with respect to all of them. So the second one that we are going to check for, so I'm just going to draw a line to separate this so that we can see that we're looking at something next, or something else, sorry. For this one, we're going to check y-axis symmetry. And remember, with y-axis symmetry, your x-coordinates change and the y-coordinates stay the same. So this time, if I were to fold it over the y-axis, all of my x-coordinates would line up with each other. So for this one, what we're going to do is we're going to replace x with our negative x. So I'm just going to take and plug into my original equation. Instead of plugging in x, I'm going to plug in negative x. And we can see with this one that if I were to square negative x, I get positive x squared plus y squared equals 4, which is also the same. So we can say that this one is symmetric with respect to the y-axis. Okay, and since it's already symmetric with respect to both of those, then it's also going to be symmetric with respect to the origin. But I want to go ahead and show you what that looks like. So for the last one, what we are going to do is, in order to be symmetric with respect to the origin, we are going to replace both x and y with negative x and negative y. So for this one, what we would do is we would type or plug in negative x squared plus negative y squared equals 4. And this is the hardest part for some people with algebra, is being able to work with variables. It's the same thing. Just remember that those all represent numbers. And if you need to plug in numbers, that's fine too. Whatever makes it easiest for you to see. But if I square both the negative x and the negative y, we already saw that that gave us the same thing. So this one is also symmetric with respect to the origin. So this is a situation where it's symmetric with respect to all of them. And the reason why this one happens to be symmetric with respect to all of them is this happens to be a circle with radius 2. So since it's a circle, if I were to graph this, and don't judge my circle, it's very hard to draw a freehand circle. if I were to draw this, I can see that all of my points, if I were to fold this one over here, they would line up with each other. If I were to fold this one, it would line up with that one. So that's the reason that it's symmetric with respect to all of them. Again, you can use a graphing utility to help graph this. If you're using the TI-84 or the TI-Nspire, you do have to have special apps in order to graph this. You could plug this into something like Desmos.com and see the circle itself. It does make it easier sometimes to see it visually to understand, because some people have trouble with dealing with the variables. As always, thanks for watching. If you have any questions, please let me know.